Alright, we're talking about integration, and of course, probably like, where's the integration at? But we'll be getting there, don't worry, and we'll be finding the area under a curve. Right now, we're just looking at sigma notation. So we're going to look at some formulas here that we've already talked about, but we're going to kind of recap over them real quick, all three of these. If we had the summation of, let's say, I equals 1 to 100, and it was of, let's say, 5. Well, I don't think we want to sit here and go, let's see, what is this going to be? 5 plus 5 plus 5 plus 5 plus 5 plus da da da, right? So we can use this formula right here, which states that I equals going from 1, which is your lower bound, to n of some constant c, and that's going to be this guy right here. And of course, this is just equal to c to the n. Now, you might have already known that, right? So this would just be 5 times 100, because there's going to be 100 of these 5s that you're going to be adding up. All right, what if we had the summation of I equals 1 to, let's say, 100 again, and this time it is I. Let's say 1,000. Okay, who's going to want to do this? This is going to end up being, now I'm just going to write a few terms out here. So you're going to end up saying 1 plus 2 plus 3 plus 4 plus dot 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 plus all the way up to 1,000. Who's got time to add all that up, right? Okay. And so the best thing to do is we're going to use that formula I equals, which we've already talked about, but we are right, and I should have wrote an equal sign. Well, I guess I could squeeze this in. There's an I right there, and let me rewrite that equal sign right here. Okay, so this is equal to n times n plus 1 over 2. So if we're to use this formula right here, n is going to be our 1,000, right? So this would just be 1,000. And of course, we get our handy dandy calculator out, or I guess you could do it by hand if you want. But I think it would be a whole lot faster doing it this way. So whatever this is equal to here, that would be the way to calculate that one. And then this was one that we just got through doing, or this is going to be one like it anyway. Let's say we're going to 20, and it's going to be I squared. So just writing out a few terms here, this would be 1 squared plus 2 squared plus 3 squared plus dot 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 plus all the way to 20 squared. But guess what? There's a formula for this one too. So this is I is it going from 1 to n of I squared, and this is going to be equal to n times n plus 1 times 2 to the n plus 1, and that's all over 6. So you would just simply take your 20 up here and you would just plug it in. You would say 20 plus 1. Of course, I'll let you work that out. And then 2 times 20 plus 1, and then the whole thing is over 6. So last but not least, let's say we had I equals 1 to, let's say, 10, and this time we had I cubed, right? So this is 10 cubed, I'm sorry, this is, start over, 1 cubed plus 2 cubed plus dot 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 plus all the way up to 10 cubed, and of course you would add that stuff up. But we have a formula for this one too, and it is just simply n squared times n plus 1 quantity squared over 4 this time, and you would just plug 10 in for n and figure out what this sum is equal to.